Hello, Algebra 1. Today we're going to start getting deeper into our linear and exponential functions. So the first thing we're going to be investigating in that regard is average rate of change. Now I already have another video where I introduce the average rate of change concept a little bit more slowly. So you might want to look at that one first. This one is just going to mainly serve as more examples. So average rate of change is going to take that idea of slope from lines and extend it to things that are not lines, random curves like this one that I have over here, and pretty much any other situation where you want to think about the change from one place to another. So average rate of change, can you guys tell me, since you watched that first video, what was it? Well, it was like something else over something else, right? It was a ratio, just like slope was a ratio. Nick, you have an idea?
Is f parentheses x2 parentheses minus f parentheses x1 parentheses.
You say that, by the way, f of x2 minus f of x1, but very nice. And then on the bottom?
x2 minus x1.
Great. So there's all kinds of different symbolic ways to think about rate of change. I'm going to argue that it's just a slope. So get it in your head with one set of symbols or with another. It's just slope, except it's not just slope for a line, it's slope for anything. So this is y values or x values on top. If you have f of something, that's always a y value. So this is y values, in other words, vertical stuff, the change vertically. So my favorite way, honestly, to think about this is to use the Greek letters from calculus and say change in y, that little triangle means change, over change in x. That's the way you'll see it in more advanced classes. I think that's even simpler, but it's up to you guys what you like best. So average rate of change is going to be the change in the y over the change in the x. So whenever you're doing average rate of change, you need to know over what interval. So it's going to be from one specific spot to another. So I've got my curve. We'll call this curve f of x, since Nick went for the f of x way to represent average rate of change. So first I want to look at the interval from 0 to 4. And when you're working these out, remember, you should write AROC, or average rate of change. The reason I write AROC is because it's a lot of work to write out average rate of change, and I get lazy. So use that abbreviation if you like, okay? So what is the average rate of change on this curve from 0 to 4? I can picture that, or I can just pump out the answers. So first I'm going to picture it for you guys. From 0 to 4 is from x equals 0, right here. Where does that hit the curve?
-7.
Looks like -7. And where does 4 hit the curve? What's the y value for 4? 0. So really, I'm looking at this line right here. You guys know what I'm saying. And I'm figuring out the slope of that line. So before we even do any calculations, can you guys tell me, is the slope of that line going to be positive or negative?
Positive.
It's positive, clearly, because as we go from the left to the right, it's going up. So we know our average rate of change, our slope, should be positive. What do you guys think? More than 1 or less than 1? Just guess. More than 1. It looks like it's a little bit steep, right? So we should get something more than 1. Let's see exactly what we get now. So I do my y values first, and you got to go in the same order. As long as you go in the same order, like up here, you can see 2 to 1, 2 to 1. As long as you go in the same order, you're going to be good to go. So what's my y value? Let's call this 0.2. My y value here is 0. My y value here is y value -7. My x value here is 4. My x value here is x, think like this. It is 0. And then the average rate of change formula. What is the symbol for change? Man, this is an important idea that'll filter through all kinds of stuff. Is it add, subtract, multiply, or divide? It's subtract. Very nice. You can see it right there in the formula. Or you can just start to think about, when I think change in math from now on, or not just in math, in my life, change is really a subtraction process, okay? So I'm going to write that in blue just to clarify that that's kind of like part of the formula. And now I just need to simplify and I'll be good to go. So minus a negative is a positive, right? And 4 minus nothing is still 4. 7/4, if we simplify it, is 1.75. You guys were right. It was more than 1. Slope. Does that make sense?
Yes.
That slope is 1.75, or 7/4. That's all average rate of change is. Don't make it harder than it is. I think the only way that people get confused about it is when they make it harder than it is. Okay, so I'm going to erase that. We good? So I've got not a lot of space. Okay, now we're going to do it for 6 to 10. And I'm probably going to go a little bit faster. So now I'm thinking, I'll draw this line as well. I'm thinking about going from here to here. And what's the slope of that line? You guys think positive or negative? Positive, more or less than 1?
Less.
Good. Let's try it. So the y value at 10 looks like, what do you guys guess? You know, you're going to have to guess. Maybe 7? Let's just say 7. 7 minus the y value at the other spot looks like 5 to me. And then we put the x's are 10 and 6, right? So 7 minus 5 is 2, 10 minus 6 is 4. The average rate of change from 6 to 10 is 1/2. The slope on that curve from 6 to 10 is 1/2. That's the idea. Okay, so that was less than 1, just like we expected. So I'm going to say 0.5 for 1/2. Okay, negative 3 to 0. I'm not going to keep drawing on there because it's just going to get too busy. We're going to get lost, okay? So negative 3 to 0 is from here to here. So it's going to be, well, I'll do one more drawing. Oh, green. Negative 3 to 0. Now it's going to be this line, the slope of that line. Clearly a negative, right? So the y value here is negative 7. Subtract. The y value there looks like about what, guys? Negative 2.5, negative 3. Let's just call it negative 2 just to make it easy. Notice I've got lots of negatives. You got to keep track. You can't leave one out. You leave one out, it's wrong. Okay, and my x values. Oh, and your x values are always right here, by the way. So don't forget, there's a pointer right there. So the first x value was 0. Second x value was negative 3. Subtract them. I do not have a ton of space, but it looks like that's negative 7 plus 2 and 0 plus 3. 2 minus 7 is 5. 0. 2 minus 7 is negative 5. 0 and 3 is 3. Negative 5/3 is a negative slope, just like we were expecting. And I think it's pretty steep, isn't it? Isn't that like negative 1.67? Which is pretty close to what the red was going up. So that totally makes sense, I think. Okay? So, what I'd like you to do, if you're watching the video or if you're in my class now, is compute these last two average rates of change for practice. So pause the video, try them out. These two, that function, go. All right, so let's look at these last two intervals. Start using the words, right? So the interval from negative 10 to negative 6, what's the average rate of change? What's the slope on that interval? So from negative 10 to negative 6, one thing you can always do is just immediately put the change in x values on the bottom, and you can just go, well, I'm going to start with negative 6, I'm going to go to negative 10. Is it okay to go the other direction? In other words, say like negative 10 here and negative 6 here? Yes. Most of the time people start with the end of the interval, which in this case is negative 6, and then subtract the beginning of the interval. That's because of various things in mathematics. It really doesn't matter though. So as long as you're consistent. What do I mean by consistent? Well, now I need to put the y values on top, right? So what y value goes with negative 6? I think that one should have been 3. It's a little hard to sometimes read my stuff. That one should have been 3. What y value goes with negative 10? I think I meant to put 3. But if you put negative 2, that's fine. So I meant to have it be negative 3. The way you can mess this up is if you switched these guys. If you said this y value went with that one and this y value went with that one, that's clearly not right. So as long as you keep your correct y values with the right ones, you'll be fine. And it doesn't matter what you start with and what you end with. I usually start with the end and subtract the beginning, but that's up to you. The key is that then, of course, I do the change, which is a subtraction problem. So I'm just going to do that over here as scratch work. 3 minus 3 is 3 plus 3. Negative 6 plus 10, that's 6, over 10 minus 6 is 4. So I think I got positive 3/2 for the slope. That definitely looks like a positive slope from -10 to -6. In fact, isn't that exactly this line? So, that's what we should have gotten right there. So positive 3/2 is 1.5. If you do the other one, I'm not even going to do it this time. Why? Let's look at where this one landed. Here's -8, and then we're supposed to go to -6 again. So really, that's just going to be this line. What's the slope of that line? Same thing. If you by chance actually do the calculation like we did with the other one, you will get the same thing if you did it correctly. This will also be 1.5. Why is that? Key thing you should write down in your notes right now. Because lines always have the same slope. They always have the same average rate of change regardless of where you're at. Okay? Very important. In other words, slope is a way to see if something's a line. If something always has the same slope, you know it's a line. If it's even off a little bit, you know it's bent. At least somewhat bent. Okay? So sloped lines always have the same slope. Let's look at another situation where instead of being given a graph, we're given a table of information. So this one keeps track of one person's age over a number of years, from when they were 3 years old to 13 years old, and it keeps track of how high they are in feet. So they were 2.5 feet tall here, and they reached 6 feet at 13 years old. So this obviously is a pretty tall kid. You know what I mean? So we're supposed to find the average rate of change for each 2-year interval. And then the main question I'm going to ask you is, when were they growing the fastest? Because average rate of change will allow us to do that. So I'm going to do a couple, then you guys are going to do a couple, we'll go from there. So what is their average rate of change from 3 to 5? So, get my clue, and I'm going to say it's a ratio, right? That's what a slope is. What are the y values for 5 and 3?
2.5 and 3.5.
Okay, so I'm going to go with the end minus the beginning. 3.5 goes with 5. 2.5 goes with 3. Change. Change on top looks like it was 1. Change on bottom looks like it was 2. So that's 1/2. But we need to think about this in context here. So this person is growing or shrinking?
Growing.
Growing. Now if we did later in their life, like when they're in their 60s and 70s, they might actually be shrinking a little bit, right? But right now they're clearly growing. So we're going to say they're growing by 1/2 what?
Feet.
Foot per year. That's how fast they're growing at that point. Now let's do 5 to 7. I'm going to give myself some more space. 5 to 7.
They're short at 7.
What's up?
Short at 7. Pretty much short.
Yeah, I don't know, I made these up. So 5 to 7. So now I'm going to say 7, 5. Which y value goes with 7 is 3 1/4. Their height at 5 was 3 1/2. Change is subtract. So on the bottom we get 2. On the top we get 0.25. I'm going to do this with fraction rules, so watch. So that's going to be 1/4 divided by 2. What's 1/4 cut in half?
1/8.
That is 1/8. Very nice. And 1/8 is a decimal. Anybody know what 1/8 is in a decimal? I'll be impressed. Yeah, we're close. Very good. You're good. It's 0.125. Okay? 0.125. So that says, how could you interpret this one? I could write it out the same way, or I could just go right here and say they grow by 1 foot every 8 years at that point. That's obviously a slower growth rate than between 3 and 5. So why don't you guys do it for 7 to 9, 9 to 11, and 11 to 13. Pause the video, try those out, and we'll see where this kid is growing at the fastest rate when we're done. Okay, so let's check our work with these final 3 average rates of change. So now we want to look at the average rate of change from 7 to 9. So 7 to 9, so I'll find the change in the x values. At 9, the y value is 4. At 7, the y value is 3.75. So that gives me 0.25 on top, 2 on the bottom. Basically, that's a quarter divided by 2. A quarter divided by 2 is, of course, an eighth. So I think we got the same average rate of change from 7 to 9 years old as from 5 to 7 years old. Basically, that just says the kid is growing at the same rate for those two intervals. And so far, we haven't found the fastest one yet either, I don't think. 9 to 11. So 9 to 11, the average rate of change is going to be change in the x's. At 11, it's 4.5. At 9, it's 4, so that's going to be a half over 2. A half over 2. A half divided by 2 is a quarter. So growing a little bit more quickly between 9 and 11 than either of these two previous intervals. From 11 to 13, let's have a look. The change in x there is 13 to 11. 13, the y value is 6. At 11, the y value is 4.5. So still 2 on the bottom, and that's the way I designed this particular problem. But of course, other average rates of change problems have no criteria that demands that you have to always have 2 on the bottom. Of course, there's nothing that says that. I just did this so we could look at the kid in a certain way. Anyway, 6 minus 4.5 is 1.5. So what's 1.5 over 2? I think that's 3/4, or 0.75. So if the question asked, like I'm going to ask you on this one, which interval did the child grow the fastest during, well, we'd want to compare our answers. It looks like they're growing pretty fast from 3 to 5 years old. In fact, they're growing at 1 foot per every 2 years, or half a foot per year. Here they're only growing 0.125 feet per year. Here they're growing at that same rate. Down here is where they're growing the fastest. And I think that makes sense because this is kind of like during puberty. So they're growing at 3 feet per 4 years, or in other words, 0.75 feet per 1 year. Make sure that you're focusing on reading those units that way. I'm taping this little addendum during my AP Stats class, and this kind of reasoning is exactly the kind of reasoning they have to use as well, and you're practicing that right now. So you want to make sure that you're reading these correctly. 3 feet, that's the y unit, per 4 years. You want to change it to over 1, then that's 0.75 feet per 1 year. So between 11 and 13 years is where this child is growing the fastest. Let's look at one more example. So far we've looked at an example with a graph, we've looked at an example with a table. Now let's look at one with pure algebra. In other words, a function. So let me get this out of the way. Okay, so I want the average rate of change for this function, x squared and all that stuff, for 0 to 2 first. So I'm going to say, well, it's the same way, change in y over change in x. So what's the change in x here? I think it's going to be 2, and I'm always going to put my change symbol in red just to clarify throughout this process. So 2 minus 0. Now I need the y values that correspond. I think I need to do a little bit of work. I've got to plug those into the function. So let's do that work off to the side, a little bit of scratch work. First I'm going to plug in 2 into the function. So that's going to be 2 squared plus 3 times 2 minus 10. Use order of operations here. So exponents first, then going to multiply, and I get 0 out for this one. So 2's y value is 0. I also need the y value for 0, so I'm going to plug in 0. You know what? I'm going to get this over here. So 0 squared plus 3 times 0 minus 10. That's nothing, so the answer is minus 10. It's oh so tempting and oh so bad for you to leave out the change. Yes, I know there's already a negative here, but this negative says the change between those two y values. So be really careful there. That's where you're going to make mistakes most likely, and then I'm going to have to take off quite a few points. So that looks like positive 10 on top, positive 2 on bottom, the average rate of change between 0 and 2 is a positive 5. We're actually going to look at this picture in a second to check our work and think about the slope. So now let's look at the interval from 2 to 4. So, same kind of idea. Take the change in the x values first. And in fact, don't we already have the y value for 2? We did it right here. It was 0. Sweet. I'll go ahead and put my change in red. So I just need to figure out what y value goes with 4. So I'll do a little more scratch work over here. So f of 4 is going to be 4 squared minus 3 times 4 minus 10. Oh, not minus, plus, right? Plus 3x. So that's going to be 16 plus 12 minus 10. 12 minus 10 is 2. 16 plus 2 is 18. So that's what I got for my y value when I plug in 4. So that's going to be, what, 18. So simplifying on this one, 18 minus 0 is 18. 4 minus 2 is 2. 18 over 2 is 9. So when we look at this graph, we should see a steeper climb between 2 and 4 than there was between 0 and 2, but they're both going to be nice and positive going up. Okay, let's have a look at negative 5 to 2. Again, I've got that same 2. I did that on purpose. So we just need to plug in negative 5. So I'm going to do that in my scratch work. Plug in negative 5. So negative 5 squared plus 3 times negative 5 minus 10. Now have a look at how I've written this down. I've made a classic Algebra 1 student mistake. What is it? Pause the video, think about what my mistake is. My mistake is basically I didn't square all of negative 5. I just squared 5 and then stuck on a negative. I need to square all of negative 5. If I square all of negative 5, the negative will be squared and turn into a positive number. Here I've got a negative 15. So really I've got 25 minus those are 25, so that's 0. So let's put this together. So the x values go from 2 to negative 5. The y value for 2 was 0. The y value for negative 5, also 0. And of course I've got to put the change in. So on top I'm going to have 0. On the bottom, minus and minus is plus. So that's 2 plus 5. Or in other words, 7. The crazy thing is that 0 divided by any number of parts is still 0, still nothing. Let's go to our graph. So I've gone ahead and put my function in my calculator. You can see it there. I'm going to go to Zoom, Standard. And if you're watching the video, make sure that you're trying on these. We're going to be using our calculator a lot next week. You need to be ready to go. So here's the graph we get for this picture. Let me scoot it over so you can see it a little bit better. So let's have a look. Between 0 and 2, 0 is right here, that looks like about right there on the graph. And 2 is right here, that looks like about there on the graph. Does the slope of that line look like it might be positive 5? In other words, up 5 over 1. In fact, I think it's up 10 over 2. That's 5. So this guy must be right. How about between 2 and 4? At 2, again, we're right here. 4 must be like way up high. Does that slope still look like it might be a little bit steeper, maybe positive 9? I think so. We can investigate further. We're just going to trust it this time. And then finally, the last average rate of change we did. Notice, this is of course not a line, so its average rate of change is different in different locations. When I go to negative 5, 1, 2, 3, 4, 5, that's where I'm at. When I go to 2, that's where I'm at. What is the slope of this line? I think we've learned that already. You should know the slope of a flat line is 0, which is what we got. So this all makes sense, whether we're working with algebra or a picture. That's what the meaning is. I'll see you next time.